Hey everyone. Hello. How's everyone's holidays? Yeah. Good?
Holidays.
Yeah. Who's got at least 2 exams left? Who's got at least 3 exams left? Well, that's good. Who's already done an exam? Okay, the pain hasn't really begun. All right. So I'm just going to be standing nearish my laptop today. I might put this up a little bit. It's mainly just because I'm manually recording. You can see up the top there on my laptop. So this isn't like recorded through Echo 360 or anything. So just to give us that ability. Don't know if any of these work. Hello. Okay. So now there's like just a few things. Why are you all here? I didn't even tell you what we're really doing.
Learning biosmosis.
Learning biosmosis. This is like a feel-good thing. No, I was asking a friend I have who's doing the course day, and I was like, why are people coming to this? I was like, revision lecture. Who made a trip into uni just for this? Shit. Okay.
No pressure.
Yeah. No, it's okay. So there's kind of 3-ish things that we want to go through. First one is we'll do a sweep of all the lecture slides, and I'll just kind of commentate it as we go through and give you a sense of like what we're like. Oh, this is kind of something to know, or how we might assess you on it, which is probably the main thing everyone's interested in. We'll also talk a little bit about what's it called? The exam. Just generally, and then there was a third thing that I've completely forgotten. But oh yeah, any questions? That was it. So if anyone has any particular questions, firstly, just while I have everyone, I just want to quickly say thank you to everyone who filled in my experience. Cool, that's a good number of people. The response rate we got was fairly high. I'm hoping that if we got the highest, then we win something. I don't know what that is. But the response rate was remarkably high. It was something like, everything's really slow, so this is becoming very undramatic. I can't even see it anymore. Who cares? Guys, who really cares? So, firstly, on the exam. So, good news and bad news. Actually, it's just bad news. I don't know why I said that. So, the exam, due to certain concerns, I'm not allowed to share with you any kind of virtual exam environment. But that doesn't mean I can't show it to you and like screen grab it and run you through it and all of that. So that's okay. It just means you can't play with it, which, like, let's be honest, most of you have done CSE exams before, and those of you who haven't, you're a university student, so you'll pick up on it very quickly. But I just wanted to give you a little bit of a rundown. There's 2 things that are still missing from this kind of environment. One is the ability to compile, and the other one is the ability to open a web browser to view CPP reference and stuff. But I just wanted to give you like a really quick rundown on what your rough exam is going to look like. Just in terms of general structure, there's just some dummy questions up here. This screen is way too small because HDMI is like crushing it. But essentially, your exam will be very straightforward. Your screen will be substantially larger than this. You'll be given a pop-up, which is essentially what we call your exam paper. And there'll be 3 sections. There's a whole bunch of stuff up the top here that's like, make sure you read this, what to do if you're sick or whatever. But the exam's broken up into 3 main sections. First section is a multiple choice section with 20 marks, where you'll be asked 20 questions worth 1 mark, and they'll look something like this. This roundabout approach, right? these may look different. We may have like a slightly different structure with it, but you'll be like, here is a question. What are the 4 types of exception safety? That I don't think that's proper English. And then there'll be 4 options, and either we'll have some checkboxes for you, or you will just type the answer into the box. And there'll be 20 questions like that. We have multiple choice for a few reasons again. One is because we're the final exam, so we only have so much time to mark you guys. Multiple choice is very efficient to mark. The other thing is that it guarantees you 25%, right? That's how the numbers work. If you assume that you're non-zero intelligence, possibly higher than 25% as well. So there'll be 20 of these questions like this, covering all topics in the course. We're then going to have some short answer questions. There'll be 15 marks worth of short answer questions. There could be 10 questions, could be 5 questions, you don't know, you'll see. And there'll be these kinds of questions. They'll be like these, by the way, all of the examples here are just exception safety questions that I've like shown how we would ask it in different types of the exam. So here it's like, what are the 4 types of exception safety? Which type of exception safety is standard vector resize? So that's a function as part of STL's vector container. So we'd ask you to write the 4 of them, and then explain like to what extent is resize exception safe out of those 4. Now, short answers are marked manually by people and their eyeballs and stuff. So this is an area where you can assume people will read it. But that being said, if we have 400 students and say 10 short answer questions each, that's 4,000 short answers that we have to mark in like 3 days. So what I would say is like, don't ramble. So generally advice with short answer is that you'll know if you know the answer. And if you don't know the answer, don't think that writing a whole bunch of crap will like magically get you the answer. Usually the less the students write, the like clearer we think, oh, they understand what they're talking about. So if you're like, what are the 4 types of exception safety? We expect people to just be like, that one, that one, that one, and that one. And then, normally we'd split this up into 2 questions, so don't worry about this. And then just ask for like a short explanation. And what type of exception safety is it? That one. You don't have to explain why. We didn't ask you to explain why. Think back to high school. Very straightforward stuff. We don't have too much short answer because the short answer is that the uni's trying to put, I think I've been told that the uni's pushing away from exams that are really heavy on English expression, just because it tends to make it unfair and make an exam about understanding of language more than understanding of C++. So that's why there's only 15 marks here. And then we have a coding section at the bottom. This one I didn't actually finish for you guys today, but it'll essentially be 25 marks worth of a series of questions. So typically you expect maybe 6 coding questions or something like that, like 5 to 9. And we'll do something. In this case, the example we gave was that we give you a file that is not very exception safe, and then we ask you to modify a particular function to make it have a strong exception safety. It might have a weak exception safety already, and we'll ask you to like give it a strong exception safety. All of the files that you have to code, so for sections 1 and 2, you only have to really interact with this exam window. You don't have to do anything else. If you want to, you can go away and compile stuff on a compiler and play around, but for section 2, but yeah, this is all done in the exam window. For section 3, what happens is that if there'll be terminals that open by default, and you can also right-click on the background and just open more terminals. And if you type ls in that folder, you'll see all of the questions that we ask you will be just sitting in the default folder. So in this case, there's a question 27.cpp that's sitting there, and if you open it with my favorite editor, you'll see that there's the file, and that's where you go and modify it. This exam environment obviously has everything you want. Did you get it? That's about it. I'm still inquiring about VS Code. There's some tricky things because this exam environment's been set up for the first time, and other boring stuff. Right now, G++ doesn't work, I believe. Yeah. That'll be fixed. Don't worry. It'd be like such a surprise to everyone, wouldn't it? Yeah, do the exam with C. GCC works though, so that's fine. Yeah, and that's pretty much it. So we'll ask you questions like this. We tell you exactly how to compile it, so you can just copy and paste that and compile your code. We show you how to run it. We tell you what to expect from it. We won't be running any tests for you. We won't be giving you auto tests, dry runs, whatever you want to call it. But what happens is when you do give it on the command line, there will be a basic compilation test, just again to sanity check that you didn't make any last minute code changes that actually don't print anything out. So that's just to give you a bit of peace of mind, but there is definitely an expectation that you will be doing your own testing. Yes, that's essentially a rundown of the vibe of the exam. I mean, your actual exam will look like this, except each section will be buffed out more. And just if it wasn't clear, once you modify your file and do all of that, you just type as it says. It might say something slightly different, but you literally just follow the instructions. Again, sorry that says .c, and then it says submission accepted, and that's all you really have to do. All of these instructions will be like repeated to you on the actual exam. But again, I am aware that we have a large number of postgraduate students who've never completed these types of exams before. Any questions? Yep.
Do we have access to documentation?
Yeah, it's a good question. Yes. So the other thing that I've had trouble getting working, I've only been working on the exam environment the last few hours, is Chromium not working. So I have to go and sort this out. It's really not that interesting. But what I have done in the meantime is that if you go to 6771 and you go down the sidebar, you can see exactly what you're going to get in the exam. So if you click on CPP reference, this is like an offline version of CPP reference. I want to give this to you beforehand, obviously, because the problem is when you're in an exam, you can't Google search stuff. So you need to get comfortable using CPP reference without Google search. Because if you're like me, right, you don't go to the homepage of CPP reference and then start trawling through the hierarchy to find your particular page. You just type into Google like standard vector. So spend a little bit of time in preparation for your exam actually figuring out where stuff is here. So you're like, oh, where's standard vector? Containers library maybe. Ah, there it is. You know what I mean? Like get your head around that. But yeah, these are all offline files. They're put up here just so you can play with it. In your actual exam environment, when you load it up, you will be given not just the exam paper, but a web browser will pop up too with all of the files in it, so you can click around with it. And yeah, just in general, for those who get concerned, if you ever get lost in this pseudo environment, just right-click on the background and you'll see a whole bunch of stuff. It's not here at the moment, but for instance, you will see something like CPP reference, and if you click that, the browser will pop up because students will inevitably close stuff. Yep.
Is there Vim or Tmux in the exam environment?
It's a good question. Oh God. What happened? Yes. We've talked about this before. Wait. Okay. We've talked about this before. I don't know how to use Vim. Yeah. So as escape. Yeah. Oh no. What have I done? QW. Okay. Thank you. Okay.
Tmux?
Tmux. What is Tmux?
Terminal multiplexer.
How do you spell it?
TMUX. Okay. And also another question.
Yep.
Are the programming questions just tested for correctness, or is there C++ style tested with them, or general style?
That's a good question. So I'm not sure actually how much my laptop picks up. So Dean, right? Yeah, Dean. So Dean just asked, are we just marking correctness or style or whatever? For your programming questions, we will just mark your, it'll just be auto mark completely on our end. So it'll be completely correctness. If your exam is borderline failing, we will probably go and just sanity check you didn't really screw something up. We don't have the resources to go and like nitpick every single person and all of the details they've made, but there will be some people, like a group of 10 or 20, who are right on the edge of failing the hurdle. We will go and look at your code and see if like there's just a really tiny mistake. We won't go and rewrite anything. But yeah, it's just correctness. Style we don't care about. We won't look at that at all. I think there was another student who asked a question like, which I haven't answered yet, which was like, can we use like using namespace std to speed up our hacking abilities? So you don't have to write std : cout and stuff. Yes, we don't care. In fact, technically, you could just write the whole exam in C, right? Like, you can. It compiles, it runs, it outputs. That's all that really matters. But yeah, that's the answer. So it's all correctness. That's a good question, Dean. In terms of TMUX and stuff, so what I would say is that the exam environment will have GCC, G++, Valgrind, GDB, gedit, Nano, Vim. Anything that you want beyond that, if you could please post soon, as in like tomorrow, probably. If you could just post on the exam page itself, just ask like, will we have this or can we please have this? Do a quick Control F to see if someone else already asked your freaking question too, please. That'd be great. Yeah, just ask that. We'll try and include what we can. There's some stuff that I know some of you might already know because you teach other courses, but like a few people have asked about VS Code. I doubt it will. The exam environment's like a sub part of the CSE system, so it's a bit different to your actual general lab environment. So I'll just have to ask some of those questions to other people. Yeah, I guess the only other thing is the hurdle. I kind of posted about this, but I just wanted to explain it in words. Most of what we just talked, that's a good point. We just talked about this and had some other questions. This is a very important note. For the first hour of the exam, it's a 3-hour exam. For the first hour, you will not be allowed to use a compiler or an editor. Essentially, you just can't compile code. This will be enforced by the people walking around, like supervising you in the exam. If you do try and use a terminal in this time, or try and write code or compile code for the first hour, and someone catches you, and you will get caught, your name will get noted and you'll probably just get like a 0 for the exam and fail the course or something like that. So just stay well clear of these things, like just don't be writing code. The reason for that's because for the first hour, multiple choice is relying on you not having access to that stuff. So we'll be asking you multiple choice questions that you'll be expected to answer without the use of a terminal. So we might give you some very trivial code questions and be like, what's the answer without the terminal? And then essentially after that 1 hour mark, we'll be like, okay, you can use terminal now, but you can't answer the multiple choice. Now in reality, what's going to happen is that, and I'm sorry I don't have it visually for you today, you'll be given 2 of these. There'll be 2 windows. One will be your section 1 and one will be your section 2 and 3. So after the first hour, you'll just be able to like close section 1 and just put that out of your mind, and the multiple choice will all be done. Just a reminder for anyone who's tempted about this, please don't go and do multiple choice questions after the first hour. After we say don't, every time you click it, we get a timestamp and we'll just read your timestamp. There's just like no scope for you to be sneaky about that, so just for your own sake, don't. Yeah, what's up, Michael? Yeah, maybe.
That's what most exams do.
Probably. It'll be something like that. Just easier to tell you the worst case. So, but I hope you can all resist the temptation. Yeah, so that's an important note. That first hour will be no terminal, which means that for the first hour, you'll pretty much be sitting here with like the multiple choice questions full screen, and you'll just be thinking about them and answering them. You can still use CPP reference though. So it's literally just your ability to compile code. I got questions about, can you take in notes? No, you can't take in notes. Can you take in blank A4 sheets of paper to do working? Yes, that's fine. So you can take in working paper and stuff. Advice would be, don't take in like a book or like 100 sheets of paper, because any paper you take in will have to get inspected for that you haven't like written stuff on it. And if you take in a book, no one's going to want to read through your entire book. So they'll just like be like, no. Anyone supervising your exam will give you paper though. So if you stress out on the day and you forget your paper, people will provide it to you. So don't go running home, getting paper and being late to the exam. Yeah, and then on the hurdle front, just to make this clear, because it's a little bit different. It's a bit more involved than other hurdles. To pass this exam, you have to score a raw mark of at least 35% in multiple choice and a raw mark of at least 30% across section 2 and 3. Right? So just to be 100% clear, because there's so many of you, someone will get confused. Multiple choice out of 20, short answer out of 25, then the final one short answer out of 15, and then the coding out of 25. What this means is that you need to get 35% for section 1, which is a total of what? Someone tell me. 7? 7? Right? So you need to get 7 out of 20 minimum for that. And for section 2 and 3, we said that you need to get a minimum of 30%, and the total of section 2 and 3 is what, 40 marks, right? So 30% of 40 marks is 12 marks. So 12 out of 40 minimum. Does that make sense? Yeah. So the reason for that is because, 30 was a good number generally, but the problem is multiple choice, you have such a high chance of getting them right. Well, you know what I mean. Like you have such a high chance of getting some of them right that 30% as a hurdle is a bit generous. And just a reminder that this hurdle means that if you've scored full marks in all of your assessments so far, all of your assignments, and you don't pass this minimum requirement of the exam, you will not pass the course. Okay, so what actually this happens on your transcript is it can come up saying that you got a mark of 62 in C++, but you failed the course. Usually it won't happen to the people in this room because you guys clearly care more than the other, 85% of the cohort and stuff. So don't overstress about it. And remember, the point of the hurdle is to catch people who are really lazy or have cheated. If you don't feel like you're really lazy and you don't feel like you've cheated, then don't stress. Like you'll hit the hurdle. Just worry about the exam. Also, these might seem like highish numbers, but also like any exam, there'll be a spread of questions from easy to hard. So you'd have to be pretty damn unintelligent to like get less than like 10% in the exam. Like there'll be questions we'll throw at you that are like, did you open Web CMS 3? So don't think that 35%'s like you're gonna get a whole bunch of hard questions. You need to get at least a third of the really hard questions because there's like easy questions to hard questions. So it'll all be okay. Any other questions about this? Otherwise, we'll just jump into content. Yep.
For the give comment, is any limit for give comment?
Any limit?
Yeah.
What do you, in terms of number of files?
Yeah, no, I mean it's like
Number of submissions.
Yes,
Yeah, 5, and then we'll lock you out. No, sorry. It's a great question, actually. So no, we won't have a limit as to the number of times you can run give. You can submit it as many times as you want. That's all good. That'd be pretty funny, though. You can only submit it once.
I think one of my courses I have a limitation for submission.
Well, tell them they're bad people. Cool. So let's just have a quick run through these. Any questions about the exam? Just like post about it or ask me here. We'll also send out summaries and all this stuff later. So, like for instance, the paper on the bringing paper in is not written here, but we'll make sure that's added there. Okay, so just a quick run through. Obviously, stuff like there's a lot of slides in the course that once you know it, and there's not much we can assess you on it. So, what a C++ program is, who really cares? Let me just see if I can very slightly turn the lights down. Or is there only 2 settings? Or I don't like slow light changes. Cool, there's not much really there. Implicit type conversions, that's an important thing to understand. What happens when you try and take a 0.0 and say bool equals it. You got to think as well, there are questions we might ask you like this in multiple choice, where we'll give you quite a straightforward question like bool b2 equals 0.0, what's the value of b2, right? True, false, 0 or 0.0, right? That might be like a multiple choice question. If it's multiple choice, we'll ask you very, very simple questions like that. If it's short answer or the coding questions where you can really go and play around a lot, you're more likely to get difficult questions. Because obviously if this was a short answer question in section 2, you can just compile it. That's pretty irrelevant. Program errors, this is really good. We might throw you an error your way and ask you like what kind of error is it? Is it a compile time error, link time error, undefined behavior, runtime? Yeah, these five would be necessary to know. Runtime logic errors are pretty straightforward. I've historically not called them runtime errors, but logic errors or runtime logic errors, whatever. If you call this one like, there'll be a bit of leniency here, but these are like exceptions being thrown. These are errors that don't necessarily crash your program but give unintended output. Basic examples are fence post errors or ones like this. Undefined behavior obviously is something that's not talked about a huge amount in some other courses, and that is where your program kind of behaves unpredictably. Right? Undefined behavior is without promise. Talked about it. I try not to explain too much stuff unless you stop me, otherwise we'll be here for like hours. Literals, just know that this works. We haven't really tested you on it, but a question could contain 20L, which means 20 long, but I probably won't put that in any of the last questions. Declarations versus definitions. This is very important. We could show you some code and ask you online, whatever, is that a declaration or a definition? What is it? Well, I can't remember the declaration one. Yeah, declaration makes known the type and the name of the variable. You can declare something as many times as you want in a program. Definitions are what actually allocates storage, memory for a particular name, and a definition can only happen once. Yes. In terms of const, there's probably not a lot of theory on const so much because like it comes up so much in the course that all this early stuff is pretty irrelevant. You could get some simple early questions in multiple choice being like, what's wrong with this code? Why doesn't I++ work? Why const? There will be some short answer questions where we ask you to explain the value of things, like why would we prefer to make this variable const? Where we'd expect an answer like because it's clearer to the programmer or it ensures no one else can modify it or something like that. We probably won't ask too many of those questions again because it does rely very heavily on your English communication abilities, which does create a little bit of unfairness. Yeah.
Sorry, so Mac, did you say we can declare a variable multiple times?
Yes. Yes.
Don't you usually get some sort of
Well, it's a little bit. Yeah, it's a little bit weird. So, where's me thing? Yeah, so one of the things about it is that when we say declare a variable, that's also defining it. So when you just do that, you're actually defining it because you actually create space on the stack at that point, so the memory's been allocated. More often with declarations, what we're referring to are things like this, like a function. So if my memory serves me correctly, this will compile successfully because you're not actually allocating any space for that function there or any of that. But yeah, it's a good question because a big misnomer is that that's a declaration. And like it is a declaration, but it's also a definition. Yeah, good question. Yeah, references, I mean, what is there to say about references? Just be familiar, we'll throw a const reference something in there at some point. And templates, this was covered in so much detail in the course that all these early things seem a bit funny now. Auto. Auto is a great example of a question we could ask you to tell us what auto might resolve to. Be like, give you some bigger piece of code, maybe an excerpt from one of the labs tutes, and be like, what is the actual type that this resolves to? It's probably a multiple choice-ish kind of question, just because it'd be a bit mean and short answer to give like a complex type, you know, because most people kind of want to see four answers. In terms of functions, default values, this could be a bit of a coding question, be like, you know, as part of a thing, like modify the function to take in default values and do all those other things. That's all kind of, who cares? Pass by reference, pass by value. That could be an explain question, why that's important. I feel like something was missing from functions. Did I just skip over it? Oh, it's later on, I guess. L values and R values. This will definitely come up a bit. Throwing more questions at you and being like, is this an L value or R value? That'd be a simple multiple choice question. A more complex multiple choice question would be some of what we did with standard forward and binding in those latter weeks, week 8, where we're like, okay, well, these arguments are passed into this function. What types are they? Are they L values, R values, const L values, const R values, stuff like that. So definitely get your head around those. Again, you don't need to do anything regarding PR values, X values, GL values, and all that stuff we talked about. You can just wash that out of your mind just for this course. Function overloading. Yeah, I mean, you guys get function overloading. But you should know how to do that as well, what that means, the implications of it. The fact that return types are ignored, right? So you probably learned this in first year, but compile error would throw if you did that, because return types are ignored with function overloading. It's only parameters and parameters that distinguish it, really. Yeah, and then const expression stuff. This ties a little bit into template metaprogramming, but this would probably be a really good question at the end of the exam, like a coding question, because there's not much we can ask about. We could give you a sample of code and be like, what line needs const expression added to it? Could give you some code and say, this code currently could be evaluated at compile time, but it doesn't, so can you please modify it so that it does? Or what are the benefits of const expression? But like, what are the trade-offs, positives and negatives? Oh yeah, Matt's stuff about Google. Header files, the linker. This is more likely to just come up with the link error stuff. I wouldn't worry too much about linking. Yeah, this is all of this stuff really here was a lead into Bazel more than anything. The good old VM. That was a fun time. Cool. Sorry to just kind of monotonously rush through this, but I mean, there's a lot of little things. I'm sure you all have places. I'm sure you don't want to be here till 5 o'clock with me. Iterators and containers. Yeah, could ask you to write some code to print out files from data to a file or data from a file, something like that. That would definitely be a section 3 kind of question. Typecasting, we could get you to typecast as well. We could give you some code that does crappy C-style casting and say, can you please modify this? We could ask you multiple choice and be like, what's the benefit of static casting over the other kind of casting? We talked about it in lectures, which is this, just trying to remember if there was an explicit thing about the casting now. Probably not. Iterating through arrays, I think this was a lead into, oh right, yeah, this is just all more introductory stuff. STL, we obviously can't really test you about draw that diagram. You could get a short answer question about why STL is good. That one's quite hard because there's so many different answers to it that it's hard to like mark essentially, because most people would say somewhat valid stuff, and you'd be like, well, that was a waste of a good assessment question. But I guess be familiar with the idea of like containers not needing to know about algorithms and algorithms not needing to know about containers. That's probably the one fundamental part of it. Might get a question about, explain how STL, how the standard template library is unique in the way it creates the relationship between containers and algorithms. We could ask you to define an iterator or give you multiple choice about like what is an iterator. It's an abstract notion of a pointer. Often I've been describing iterators as they're basically just linear abstractions of a pointer, because pretty much every iterator you move through things linearly. There's not a lot here. I think in terms of iterators, with all the .start, .end stuff, there's a lot of scope to get questions about, is this an invalid iterator? Has this gone past the end? What's wrong with this code? Or give you broken code and say you need to adjust it. Give you code and say, let's go through this in reverse or something like that. Iterator categories, definitely know about these. There's really not a lot to it. You could look at this and be like, oh, I need to remember a table. But reality is we're really going to only ask you about these 3 types. So only concern yourselves with these 3 types. And then once you realize that these 3 types all have read access, all have, have the freaking whatever it's called access, all have write access, the other stuff you barely even need to remember because it kind of makes sense, right? Like you can only really do index on random access iterators because indexing is random access, and then to do minus or plus equals or minus equals involves jumping an arbitrary number of steps, right? Which is also random access. It's like jumping from one index to another. And to be honest with you, those differences you don't even need to remember. We could ask you in an exam and you'd be able to just think about it. But just be aware you need to know it. And then for the compare stuff, random access has that as well. Could ask you which one's more powerful than the other, blah, blah, blah. Iterated categories. Maybe be familiar with an example of some of these, like what container or what remember that with iterators, you got containers that provide certain capability iterators, certain category iterators, and then you've got algorithms that expect certain category iterators. So if we were to say, ask you like name, which of the following algorithms expect a minimum of random access iterator, and we were like, replace, reverse, binary search, and sort. There you go. There's a multiple choice question that requires you to think about that. You don't need to remember them all again. You could imagine yourself writing some of these algorithms, and you're like, could I write a sorting algorithm with just bidirectional? I mean, yeah, I guess. You wouldn't want to. But just little nuggets like that would help. Streams. This really just ties into the file opening and closing thing, so that's nothing particularly new. STL containers, you don't have to memorize this diagram at all. A lot of this you can find on CPP reference anyway. Nearly all member functions of these particular containers they specify the time complexity or space complexity for them, so you don't really need to remember any of that. It'd be really good if you know what these 5 types are. Vectors, dynamically sized array, doubly linked list, singly linked list, vector with fast operations from beginning, C-style wrapper for array. They're pretty straightforward. Vector, because we could ask you have CPP reference. I guess it'd be pretty easy to look that up. Anyway. That's not really anything, that's just showing off vector. So, understanding the difference between sequential containers and associative containers is also relevant. remember that sequential containers are like lists, and associative containers are value key pairs. So maps and sets are all associative containers. Sorry. That's just a map example. Who cares? Cool. 2.2. Is everyone having a good time? Is this helpful? Yeah? Okay. Good. Shit. I was like, it's good. Oh, common mistakes. Bazel won't sync properly. Should just show you like a, throw like a, I was actually tempted a few nights ago. I was like, give like a question one that just like is a really obscure Bazel question. And we'll just like not mark anyone on it. No, you'd all get very mad. Starting your assignment, profiling, Git, debugging. Irrelevant. Principle of testing. Ooh, that's good. We may ask you to write, so when we say coding questions, what we're really meaning is written questions in an editor of some sort. So one of the coding questions we could ask is like, here's some code, can you write some basic pseudocode tests for it? You know, like kind of like catch-2 tests, except we're not expecting you to know catch-2 syntax off the top of your head, right? Because who the hell does? So we might ask you to do that, or we could kind of throw some tests at you and be like, these tests were intended to be interface testing. What's wrong with them? Something like this. From a testing standpoint, the main things to take away are that you have unit tests, which are like testing atomic parts of the implementation. They're like getting right into the guts and bones of what you're testing. And then we've got interface testing, API testing, behavior testing, right? Because that's why we call our tests in our assignments BDD, behavior-driven development, because they're behavior tests. And this is where we test just like the public interface of it, just like testing ADTs or whatever you will. Understanding that difference is important. Understanding how to make tests simple is good too. In particular, not putting like if statements or loops in your tests and breaking up tests, making sure that tests don't rely on each other very much. If you get questions about testing, they'll be quite straightforward ones like that. That would just be checking whether you listen to what I've just said then, really. Build rules, testing in general. You know what I always used to enjoy as a student? Clicking through a lecture slide and being like, don't need to learn that. That was always fun. Common algorithms. Great. What is that algorithms? Not a lot here. Knowing that this uses .begin and .end under the hood is important. Remember that this uses the same begin and end iterators. Just because it's a for range loop, it doesn't mean it just magically figures it out. Nah. Yeah, I guess there will be cases where you could be asked to take a piece of code that's fairly C-like or inefficient, maybe be asked to rewrite it using some STL containers or algorithms, which kind of reminds me that if you do get asked questions, there's a couple questions we haven't finished in the exam. There will be questions you may get asked to put stuff in a text editor that will be like manually marked, right? So like Dean asked before about correctness and auto marking and stuff. If a question is manually marked, we will like explicitly write that and be like, this will not be automatically marked for correctness. This will be manually marked. I'm just not sure whether those questions will come up in short answer or the coding questions. It'll make sense to you either way, but yeah, because the thing is we can't say like, go and convert this program to like use some STL containers and STL algorithms instead without manually marking it, because the correctness mark would be irrelevant because the code should do the exact same thing it was doing before you touched it, right? So that stuff has to be manually marked. Performance, there'll be nothing about performance in the exam in terms of us asking you to write code that adds a performance. there might be a particular question that's like, you know, this container has a higher performance, or like one of the old questions is like, this one's a bit of a mean question to ask, and I guess I can't ask it now that I've said it, but like what's the difference between, you know how there's like std find in algorithms, and then there's like std std. Then I think it's set has a find as well, right? So set actually has a find function built into it that doesn't need like an STL algorithm to be used. If you just clicked around on CPP reference, you'd notice that set find is substantially faster. That's pretty obvious because it's a method of a class, so it knows how it's implemented. So naturally it's going to be a lot quicker because it's not having to deal with like a linear abstraction of it. That'd be a bit of a mean question because I think there's a few steps you got to make in your brain. But yeah, that's the kind of way we might ask you about performance. We won't so much be like assignment 1, rewrite this code so that it runs in 0.1 second or anything like that. Someone found that quite funny. Lambda functions, lambdas, yeah, look, get familiar with how they work. Just remember the captures and the, I've been saying this to my tutes and stuff, I always just remember lambdas because it's just captures and it's all 3 brackets just lined up like that. You got your captures, your parameters, and then your actual body. That's how they work. If you capture things by reference or by value, that's different. Go back to a tute or go back to lectures. Could be a question on that. Yeah, this is all just covering that. Again, I'm trying not to be here to explain stuff to you. That's the end of algorithms. I'm just gonna, yeah.
Are there gonna be like practice questions or practice coming up?
Yes. We kind of have like big sets of questions, and we're just finalizing which ones go on the exam, and whatever ones don't go on the exam we'll be giving out. So I haven't given any out just in case it's like we're like that. Find that one's better. That's something ideally in the next few days. There won't be like substantial amounts, but you'll get kind of a taste of what the exam's like. Imagine having like enough questions to do like a 1-hour mini exam. Again, I apologize about not having a huge amount. Largely in most courses, the reason there's so many practice questions is because they just keep regurgitating previous years and stuff. But previous year's exams used to be all done on paper and we're a bit different. So there's not a lot. We have to like write everything up ourselves. Understanding scope's really important. What are the different scopes? From like local scope in a function to, you know, class scope to namespace to global scope and all of that, or just creating your own scope with braces. There's some tricky questions we can ask you in multiple choice regarding scope, so get your head around scope. Object lifetimes is all just the same stuff about scope. Construction. Remembering the difference between the braces and the parentheses when it comes to construction. Right, so like braces are all initializer lists. Unless it doesn't exist, then it just behaves like parentheses. So getting your head around that. No except. We're not going to test anything on no except. You don't need to know no except. Destructors, I mean, there's not a lot to destructors except they're called once the object's lifetime ends or it goes out of scope. OOP, know the definitions of abstraction and encapsulation, interface and implementation. They'd all be important to know. I don't think there's much really on classes, like we probably won't test. I mean, all of this is kind of assumed knowledge anyway from previous courses, so it'll just come up implicitly. Same stuff here, incomplete types. Yeah, nah, don't worry about that. Classes are structs, close enough. The only difference is that. So know that difference between classes and structs. Friends, yes, you definitely have to understand friends. You might have to implement some friends. That's a near given. You may have to understand friends to provide some solutions. We also might ask you to write something in relation to operator overloading, which is how friends have come up a lot in the past. Class scope, we all get class scope. When I say like we all get this, by the way, that just means like it could be on the exam. It's just like not like a topic we assess. It's just part of stuff you probably know, like assumed knowledge, like const, right? Like we all get const. It's going to come up on the exam, but you don't need to study for the const question. That is another example of something you should all know because of 2511 or 2911. There won't be anything about mutable on the exam, so you don't need to check that. Those examples are good to understand. Constructors, yep, so how an object's constructed is important. It follows certain behaviors and patterns. You need to understand this and know this. You don't need to write it out word for word, but you need to know the flow. That's all stuff to know as well. Initialize a list, like this is stuff to know. Delegating constructors, that's when a constructor, like, instead of being explicit what it does, it just calls another constructor with like explicit arguments. So typically you'll have a constructor that takes in a name and an age, and then you'll have a default constructor that just calls the more specific constructor with a default name and a default age. Static, again, this is all assumed knowledge prior to the course, but make sure you have your head around static. Explicit type conversions, I don't think you need to concern yourself with that slide. OOP design, it's too hard. No. They talk about delete and default here. Just because I say no, that comes up later in the course. If you remember around like week 6, 7, you do need to know default and delete. Like, when it comes to like copy constructors and move constructors, how you can write the prototype equals delete to say there is no move constructor for this type. So you need to know that. This is all Matt was talking about here anyway. All of this stuff's important. It just seems like it's all move constructors and copy constructors and move assignments and stuff. There's not a lot to it though. So that's pretty chill. I'm probably going to skip over the operator overloading slides very, very quickly because if you remember, this was just a whole bunch of examples and you kind of need to understand it all anyway, and all of you have done 2 assignments on it, so you should understand it all anyway. This is very likely to come up in some way, shape or form, but I like to think that we don't need to talk about it much because you should get it all. These are all of the operators you can overload. Maybe go and have a look at the ones that came up less than you expected in the assignment, such as plus, plus, minus, minus, the call one, relational also didn't come up really in the assignments at all. Particularly the, relational. Equality came up, but relational. So just check those ones out. Because they're probably like less intuitive to you and there might be like a subtle difference with them. The only other thing is that we may also ask about the type overload. This was again in your assignments. This is when your like graph gets converted to a vector. This is your Euclidean vector could get converted implicitly to a vector or a list if it was static cast that way. 5.1. A lot more to this course than I thought. Object lifetimes, this is just scope stuff again. Smart pointers is probably a pretty straightforward topic to prepare for because the concept behind them is quite straightforward. You have raw pointers are dangerous because you can lose them. So you wrap them, which is like a heap object, a pointer to a heap item. So you wrap the pointer in a smart pointer, which means that a stack item manages it. And then when the stack item goes out of scope, it drags the heap item along with it, right? That's smart pointers. A lot of these slides will be getting your head around it, more than actual like theory you need to know. Probably the key thing is that typically we either use unique pointers and raw pointers, or what we call observers, or shared pointers and weak pointers. That's really it. You could get asked a question about it, saying like, what's wrong with this code, or like, how would you fix this code? This is a great question to be given in the practical section and be like, here is some code without smart pointers. Can you please go and add smart pointers to it? It's just reminding me that some of your questions for section 3 will have to be manually marked anyway. So back to Dean's question earlier, whether we say this question will not be automatically marked or will be manually marked, or whether we're like, whatever it is, you will be made clear of that and it will be quite obvious to you. Shared pointers, like, you guys just need to understand this stuff. When to use the difference, that's probably a good example. So short answer question might be like, here's some code, here's an explanation of some code, here's some code, here's how it's used. Is the use of shared pointers and weak pointers here more appropriate than unique pointers? Yes or no? And if so, why? Right, it's like a prime short answer kind of question. Please, again, just stop me at any time. I'm just trying to make sure we kind of finish this up in the next 20 or so minutes. Exceptions. Understand the definition of an exception, that it's to handle runtime anomalies. That's probably the key one. Yeah, I mean, this is all important. Understanding the try, catch, catch is important. Understanding multiple catches. Understanding rethrowing is also important, right? And then in terms of catching, talking about, like, do we catch by value, pointer, reference? Obviously reference. Why do we catch by reference? Be prepared to know that they're the two reasons, right? It's more efficient and there's no slicing problem, which we talked about in week 10, which is from polymorphism in week 9. These are just examples to get your head around it if you're struggling. The harder part of exceptions, stack unwinding. Most of the exception stuff's pretty straightforward. Stack unwinding is a bit more complicated. This is also another example of times that are good to know the definitions, multiple choice questions or whatever. So processing of exiting the stack frames, right? Basically moving back through functions, if frames is a bit weird for you, until we find an exception handler, and if we don't find one, we call standard terminate and quit the program. That's just how to describe the behavior of exceptions being thrown. Then it's important to know a couple of other things about stack unwinding, which is the old, if an exception is thrown and not caught, if an exception tries to unwind out of a destructor, then standard terminate's thrown, because any exceptions in destructors have to be caught, otherwise terminate will be called. And also the notion of partial construction, which is that if exceptions are thrown and not handled in a constructor, the destructor will not be called. Right? So anything that's been created on the stack for that object will get removed, but the destructor will not be called. So partial construction also plays into smart pointers a bit. So the stock standard example that you're used to seeing is, if you have a look just where my mouse is here, where how this is constructed versus how this is constructed versus how that was constructed versus how this is constructed, right? Like, that distinction is somewhat important. Just the use of smart pointers there to prevent any issues with partial construction. Exception safety levels, know them, live them, breathe them. There's not a lot to it here. It's unlikely we're going to ask you to elaborate on any of these in detail. If you could describe them all in a phrase or two, like no-throw guarantee is that exceptions may occur but are handled internally, right? So no exceptions ever bubble out. Strong exception safety is that exceptions may be thrown, but anything will be rolled back to the original state before the call. Weak exception safety is that there may be side effects, but no resources are leaked. And no exception safety is like, no guarantees. That's about it. No except, who cares about that one? Well, I mean, it's important, but not for your exam. Okay, 6.1. What was topic 6? Who knows? Anyone? Hey? Templates. Who said templates? Good. Very good. I give you the first mark free. Generic programming. In terms of generic programming, the key part of understanding that definition is you're trying to create code that operates independent of the underlying type. It's kind of what a vector is, right? Like, you don't even need to really remember it word for word. It's like, what's cool about a vector's templated, which means that it operates regardless of the type it stores. Same behavior, no matter what the type it stores is. Function templates. I feel like we've just talked. We need to understand all the templates. Type and non-type parameters, these are important to know. Remember, non-type parameters are when, that's just hard to read, isn't it? Are when you have the actual type of something inside of the template line. Class templates, classes can be templates or functions can be templates. There's a couple of key issues here, which is, I don't think there's many theoretical things to understand. This is a really cool slide back to week 3, really, which like kind of shows you how a default rule of 5 would be generated. Remember, the rule of 5 is copy, construction, assignment, move, construction, assignment, and destructor. That could be a question. Default, so this default and delete. This was the example. You can actually go back to the lecture recordings and listen to it, how we talked about that. The constructor, a default constructor will be created if you don't specify a constructor. But once you specify a constructor, all other constructors will not be default constructed. Well, the default constructor will not be default constructed. So there was a little few minutes we talked in the lectures about how like, how the default constructor exists, but once we uncomment this line, we can't default construct it anymore unless we manually write stack bracket bracket equals default. And then also it was talking about delete and how you can write delete to specify, no, I don't want a default constructor, please. Cool. That was templates. Templates part 2. Inclusion compilation model. This was just talking about why we cannot put our template files in .cpp files, why we have to do that whole hash include .tpp inside the .h file. That's the important piece of theory to understand, whether you have to describe it or a piece of code comes up relevant to understanding it. Again, this was covered fine in the slides. You can actually just play around with this. You don't have to go back to the recordings. It'll be very obvious what's going wrong because it won't let you do it. You don't need to know anything about explicit instantiations either. Don't worry about any of that. Static members, yes, you need to understand how templates work with all of these things like static members and friends. You could get asked about, here is some code, and then here is a couple of instantiations. How many of these friends were instantiated at compile time, right? And as you know that each instantiation of a stack has one unique instantiation of a friend. So that means that if we have some kind of stack and we create a stack double and the stack int and a stack like float, that the function that we had, which would have been like our friend bool operator equals, you know, like const stack, you get what I mean, like that kind of thing. We know that how many of these functions would have been instantiated? Well, exactly however many you know, stacks were instantiated. So in this case, 3. default members, yeah. That's just defaulting template types. Remember, this whole slide's just for that little part up there. 8.1. This stuff is where you might get to the harder questions in the course. Default members were from the previous thing, we just copied and pasted them in. Understand how to describe partial specialization and explicit specialization. Partial specialization is describing the template for another form of the template. That's probably if you need to remember a line because you don't feel comfortable explaining it, just remember that. But the general gist I always have been telling people is partial specialization is where you specialize your template, but the template type is still in the definition, right? So the oldest example is obviously when you do something like stack for type T star or a pointer to T. You've specialized it, but in a way that the template still exists, the type still exists. So that's partial. And explicit is when it's actually specified to a specific type, like a non-generic, non-templated type. So the type in your code is no longer T or some other generic, it's now like int or double. Some of this stuff, you don't need to worry too much about explaining standard vector or bool or anything like that. You do need to know that, and we've talked about this in lectures before, that the reason you want to partially specialize classes is to provide function. Remember, with any kind of specialization, it is to provide, to make it work when it otherwise wouldn't compile, or to provide some kind of space or time complexity improvement such that it doesn't change the semantic of the functional class, right? So it's basically to fix it, to make it better, to make it faster, such that it doesn't do something different or doesn't confuse the user. Understanding that, or that, you know, having to explain that, that's kind of the crux of it. This kind of just goes through it in more detail regarding like partial and explicit specialization and gives some examples so you can get your head around it. Type traits. Type traits were just these cool little staticky, structy things with static stuff. You know, it's like numeric limits. We might ask you to write a type trait. Like you go back to week 9, Tude, I think, and we asked you to write some type traits for like is pointer. That's a question you very well might likely get. It's a very easy one to compile and check for correctness. By the way, just with the correctness thing. So there are questions we will check your correctness for, but that doesn't mean you can write genuine bullshit. Like the last exam I ran in term 1, you get students who would literally just like hard code the answer, right? Like they know what it outputs. So what happens is that when we get all your questions, I basically open up all of your answers in, say, Atom or Sublime, like 400 tabs, and then I just sit there hitting the close button and just like quickly look at them, and a bad answer looks like a bad answer. You notice it very, very quickly because everyone's answer looks roughly the same. I just want to tell you that so that like you don't do that. Don't do it even if you're like, oh, there's 5 minutes left, I don't know how to do it, maybe I can get some marks if I just get an output working. Just don't do that, because you'll get seen and you won't get any marks and you'll have just wasted time. So yeah, type traits are a very good thing to know because we might ask you questions on them. Get your head around those. Variadic templates. We didn't cover these in a lot of depth. So this is more likely to be something that might pop up in multiple choice, being like, here's some code, what would this output? And something fairly trivial as well. we wouldn't ask you to write anything about variadic templates, so you don't have to assume. You can assume you don't have to code any of this up. People's keyboards are like frantically like, don't need to learn this. Yes. Such enthusiasm for a lack of enthusiasm. Yeah, very funny. Member templates. So member templates were when we basically started adding template type name T2 into our template. So that was when we had cases where you'd have a templated type T that wants to operate on another templated type T2. So you'd have a template with inside. Oh, that's creepy. You'd have like a templated method within your templated class. We didn't give too many examples on this, so like this may come up. If it does come up, it won't be overly challenging. So it'll only be as hard as these kind of examples are here. Template parameters, same kind of thing. Remember, these all came up to create a situation where you could just write stack int and then standard vector, and you didn't have to give standard vector a type. These are very challenging to code up without knowledge, so if this was to come up, it would either come up as like a multiple choice question or a short answer question, maybe just showing you the broken code and being like, you know, where is it? Maybe just, I don't know where it is, somewhere. Yeah, maybe just showing you code without it and being like, how can we improve this? Like, yeah, sorry, it's right in the freaking slide. You know, giving you a piece of code like this and being like, inspin mentioned twice here, how could we resolve this? And you're just like, through the use of template parameters, something like that. That could be the easiest form of it. The hardest form would be a question like this could come up as like the tail end final question on the exam where we just give you the code and we say make it work, right? Could come up. That'd be one of the harder ones though. More examples here. Template argument deduction. This is an important thing to know. The process of determining the types of type parameters and the values of non-type parameters from the arguments passed in. Because remember that when you write code, like this one, find min, I just like copy that. You don't always write standard cout find min. Like, you know, you might, what's the example? You might have some code that looks like this. Int a 3 equals 1, 2, 3. Right, you might have something like that. And you notice that you haven't actually had to specify what the type is for your template. You haven't actually had to go int 3. Right, that's you explicitly telling the compiler how to deduce the arguments there. So template argument deduction is essentially the process by which you don't have to do that. It's described here. Could get a question on it too. Yeah, understand implicit deduction as in like what are the ways that templates could be implicitly deduced, or like we could give you a question. You get this stuff. It's pretty much just like here, this is a deduction that's very clear. It's like I pass in an int and it's looking for a type t, so the type t is int. And this slide is essentially saying sure, but there's also some implicit steps in between we might do, such as convert from non-const to const, convert from array to pointer, or convert from derived to base class. And this is just talking about doing it explicitly. Okay, advanced types, decal type. Get your head around these rules. This will definitely be somewhere in the harder part of the exam, being like, what is this type? Probably multiple choice, maybe short answer. Could ask you to, maybe some code like this too could come up, like asking you to write some code like this. This is all the same stuff. This is more type trait-ish stuff, so just like type traits, this is dealing with structs that actually do type conversions for us. This is the harder stuff, such as adding R-value references or checking if they're the same. This is all just type traits. You can go and get familiar with lots of it. Binding, we talked about binding a lot in the last couple of weeks. This table is really good to know. Thankfully, it's really easy to know, as I've said to people before, because template R-value references bind to everything. References to const t bind to everything. So that's half your load done. That's a pretty easy thing to remember. You just have to remember two things. And then the only other ones to remember, what does a reference to t bind to and what does an R-value reference to t bind to? Well, L-value references to t bind to L values and R-value references to t bind to R values. It's a very straightforward table. This could come up anywhere in the exam. You could get asked, particularly if it comes up in coding, it'll be to do with standard forward and some of those harder examples we saw in the last weeks. Just some examples of that. Forwarding. This is some slides Matt put together, which were basically just like taking you through it. This is good revision to kind of get your head around the theory of it. But then if you want to really get a better sense of standard forward, go and have a look at the actual tute questions that were in week 10 and take your time going through those. This was added, I think, recently too. So I think students were asking about uses of standard forward. Could get a question about why you'd want to use standard forward as well. Runtime polymorphism. So this is the one lecture in the course that I wasn't really there for. So I know I'm writing the damn exam, so I get it. But there might be a couple of slides that I'm like, I never fully got my head around what Matt was saying there. Understand these ideas, right? Inheritance. You won't get asked the maybe. There's no point me saying you won't get asked unless you really won't get asked. Just understand these ones. We won't ever ask you to define polymorphism. We'll either ask you to define static polymorphism, which is just templates or generic programming, or we'd ask you to define dynamic polymorphism, which is what we refer to here as polymorphism. That won't come up in the exam. Private, protected, public could come up. Could get asked questions about usage of it, such as in your tutes. We could ask you to actually create subclasses or derived classes from base classes. So it could give you some base classes and say, go and create a derived class with a different kind of behavior. This is how we're going to test it. Could ask you why no, nothing there. Is this anyone's first attendance of lectures this term? Okay, I just want to check. I thought that'd be funny. You never know. You never know with revision tutes because there's two types of people in here. There's ones that have come to everything and they're like, oh, I'm already on the bandwagon. I might as well come. It's just I see Richard there. Richard's been with me since the beginning. Hey, Richard. And then there's another type of person who's the one who's like, I'm screwed. It's time to start paying attention now. Inheritance and memory layout. Yes, definitely. So this starts to get into all the V-table stuff as well. Definitely need to get your head around this. I don't want to specify anything here because Matt has gone through the stuff in the lectures and he may have used basically any inheritance polymorphism questions in the exam Matt will write just because he spoke it to you. So I want to make sure there's consistency there. But yeah, definitely memory layout and stuff. That yes to, that's all fine. Polymorphism and values. Yes, understanding the size of things. These are great questions to come up in multiple choice as well. Object slicing, this also comes back to exceptions. They might come up in the same question. That's all just about how, what's the example here we have? Yeah, play around with that example. It'll make sense. Which, this is all stuff you need to know. Virtual functions, just about how to like override, right? So, if something can be overwritten, it needs to be marked as virtual. If it is overwritten, it needs to be marked as override. You don't need to like remember that it doesn't have to be used. Just assume that it should be used. It's good to know, like, you know, override fails to compile. That could be a multiple choice question. Why doesn't this code? We're not going to ask many, if any, why doesn't this code compile things. I've made my case on that. I think that's a cruel thing to do to people. But it may come up once or twice, just because it's a little bit fun, and you can ask some interesting questions. But yeah, all of this too. V-tables, important to know. You're not going to get asked to draw any V-tables or anything like that. So naturally, this will come up more in multiple choice or short answer, asking you to describe a problem, like explaining, like using V-tables, or a multiple choice question, including some images or something. We might be like, what does the V-table look like for this? Here's 4 possibilities. For final... Yeah, same thing, need to know that too. Abstract base classes. Yeah, I mean, you should also know this from 2511, unless that course has changed since I last taught it. Which is pretty much that, like, we have classes that we want other things to inherit, but they themselves can't be instantiated. So that's good to know. Abstract base classes, ABCs. Creating polymorphic objects. Yeah, I'm just trying to remember if this one was around. Oh, sure. I think this all just falls back to slicing stuff. So these slides are like good to get your head around, but we're not going to like pick on them so much for a question. Static and dynamic binding, you definitely need to understand, because, well, you know, it's part of the course. But yeah, you could get asked questions about, is this one, like, you know, what is this one static type and this one's dynamic type? There are good questions in week 10 about that as well. Upcasting, yes. Downcasting, no. Yes, you need to know these two things, and that's just how we're going to refer to it. And yes, proper downcasting as well. You can kind of tell that these are the harder end of this is the harder end of the course as well. So this obviously has a chunk of stuff on the exam, and it is harder. So yeah, one piece of advice, just study advice as well, is I'd probably recommend just starting from the end of the course and working backwards, because you all know how study works. You leave 9 days for 9 topics, and then you spend 1.5 days doing the first topic, and then 1.5 days doing the second topic, and then by the time you get to the end, you're like reading polymorphism on the bus coming into Randwick. Types of functions, don't worry about that stuff. Covariance. I'm honestly not sure if Matt wants to ask a question on that one yet, so just definitely assume that's this stuff's still relevant. That stuff's relevant. That stuff's relevant. I mean, this stuff's like... For a lot of this, just take your time and go through it. I know, like, the problem with polymorphism is that, unlike a lot of the other topics, you haven't had a strong chance to play around with it, right? Like, you did your assignments, you didn't have a lot to do with exceptions, but you get exceptions because you've done it before. And then templates, there's a little bit of it in your assignments, and everyone struggled with it a bit. So I would definitely recommend people spend a disproportionate amount of time on polymorphism. Not just because it's a bit harder, but again, because you're less familiar with it. So like really like comb through these slides and stuff. And as always, if you have questions, just post on the actual polymorphism slides pages or the tutors or whatever. Yeah. A lot of stuff in that last one, even more than I remember. Yeah, that's kind of everything. I don't think we ever ended up having anything in this slide deck. I think it was like abysmally empty. Yeah. Okay. That's irrelevant. I felt bad actually because I don't know if you guys saw, there was like one person who didn't watch the lecture recordings and they're like, hey, what's up with that last one? I thought there was going to be revision content in there. Sorry, I just think I snapped my cable. Cool. Any other questions? I know that I said like 3 to 4 and it's 4:30 and most of you are here because you don't mind about the time. But any last questions?
How many questions will be involved in the exam?
How many questions?
Yeah.
I don't know how many questions. It's 60 marks. If I had to guess, let's assume your average short answer is going to be 2 marks and your average coding question might be 3 marks. Then you're looking at 8, 7, 15. You're looking at like 35 questions, 20 multiple choice, maybe 7 short answer, maybe 7 or 8 coding stuff. Coding we will tend to avoid big questions unless it's manually marked, because it's in my opinion fairly unethical to give someone a 7 mark like all or nothing question that's like auto marked. So a lot of the auto marked ones will tend to be a bit more atomic in nature. I'll also upload this. It's just recorded. I'll just upload it pretty easily. Yep. What's happening on Monday? That's an excellent question. Whatever you guys want. I don't mind. I'm literally just going to come in and chat to you. We can chat about topics. We can chat about the exam. We can anything. But yeah, I assume many of you will not care about coming on Monday. It was only put there to kind of bring comfort to the people who still don't care about their exam today. And that will come through to them on the weekend. Cool. Okay, thanks guys. If you have any questions, come chat to me.